Hello everyone, welcome to my channel. This is the seventh lecture series in my data science course. In this video, we will start our seventh unit, naive Bayes classification. In this video, we will explore naive Bayes classification, a powerful tool for data science applications. Let's start. First is what is naive Bayes classification? So it includes probabilistic model and Bayes theorem. What is probabilistic model? It means naive Bayes classification is a probabilistic algorithm that predicts the probability of a data point belonging to a particular class based on its attributes. Next is Bayes theorem. It means it uses Bayes theorem to calculate the probability of a class given the values of its attributes. This makes it a useful tool for data mining and classification tasks. Next is assumptions. Assumptions in naive Bayes classification. It includes conditional independence, prior probability, and likelihood. Conditional independence means attributes are assumed to be independent of each other, meaning the value of one attribute doesn't influence the value of another. Prior probability means naive Bayes relies on the prior probability of each class, which is the likelihood of a data point belonging to that class before considering the attributes. Next is likelihood. Naive Bayes calculates the likelihood of each attribute value given a specific class. It assumes that the attributes are independent of each other. Next is advantages and disadvantages of naive Bayes classification. So what is advantages of naive Bayes classification? First, it simplicity and ease of implementation. Second is effective for high dimensional data sets. Third is relatively fast training times. And next is disadvantages of naive Bayes classification. First is assumption of conditional independence can be unrealistic. Second is can be sensitive to noisy data. Third is may not perform well for complex datasets. Next is applications of naive Bayes classification. It includes spam filtering, sentiment analysis, medical diagnosis. Spam filtering. Naive Bayes is widely used for spam detection in email systems. Sentiment analysis. It can classify text as positive, negative, or neutral, helping understand customer feedback. Next is medical diagnosis. It means naive Bayes can assist in diagnosing diseases based on patient symptoms. Next is how naive Bayes works. It includes two steps, training phase and prediction phase. So first is training phase. The algorithm learns from labeled data by calculating the probabilities of different classes and attributes. Next is prediction phase. The algorithm uses the calculated probabilities to predict the class of a new unseen data point. Next is limitations of naive Bayes classification. So, limitations of naive Bayes classification are zero frequency problem, assumption of independence, sensitivity to irrelevant attribute. So, what zero frequency problem means? If an attribute value doesn't appear in the training data, naive Bayes may assign it a probability of zero. Assumption of independence means the assumption of conditional independence may not hold in many real world scenarios. Sensitivity to irrelevant attribute means irrelevant attributes can negatively impact the performance of the algorithm. Next is conclusion of naive Bayes classification. Naive Bayes classification is a simple and powerful algorithm with numerous applications in data science. Understanding its assumptions and limitation is essential for effective use. So now we understand how to demonstrate the application of naive Bayes using Python. For that we are using Google Colab. So here it is. So this is the code for how we demonstrate application or how we implement application of naive Bayes using Python. So in this code, firstly we are importing libraries like load iris to get the data set, train test split to divide the data, Gaussian NB for the naive Bayes model, and some tools to measure accuracy. Next, we load the iris dataset. It has flower measurement like petal and sepal length and their species. Next is split data. We split the data into two parts: training data to train the model and test data to check its performance. Next is train the model. In this, we create a naive Bayes model using Gaussian NB and train it with the training data. Next, we are making predictions. The model predicts the species of flowers in the test data. Next is evaluate the model. It means finally we check how well the model did using accuracy, a confusion matrix, and a classification report. So let's execute this code. Wait, it will take few time. So it's executed successfully, and this is our output. So the output shows the model's accuracy is 95.5%, meaning it correctly predicts the flower species most of the time. The classification report provides matrices like precision and recall for each class, indicating how well the model performs for each flower type. The confusion matrix compares actual versus predicted values, showing most predictions are correct with very few mistakes. So this is our naive Bayes classification, and we discuss how we demonstrate application of naive Bayes using Python. So that's all for this video. We will meet in the next video. Thank you.